Assalamu alaikum. I would like to welcome you into this video. This is lecture number 4 in the series of our C++ course. In this lecture, we will finish chapter 1. In the last lecture, we stopped at chapter 1, part A, and we discussed how to write a simple program and have test drive it on the real compiler. And in this lecture of today, we will continue part B of chapter 1. The main objectives of this lecture today is to write a simple computer program in C++, to write a simple input-output stream which continues what we've done last lecture, and to use fundamental types and arithmetic operators, as well as the precedence and arithmetic operators, and finally to write a simple decision-making statements where we will have our computer to make a decision either to take this part or that part, and this is the main concept that upon which we could write smart programs to make their own decisions. Now, saying that, we should start by explaining fundamental types and arithmetic operators. Types and arithmetic operators. As you all know, in C++, we are really somewhat attached to the keyboard, so we're not really free to write mathematics the way we do in normal math class, calculus, differential equations, or any math class we took before. I mean, we don't write math in, let's see, in this way. We cannot type this in a computer and have the compiler just understand in this format. So we have to sort of transform this notation into a notation that a computer can understand, and this is what we're gonna do just in a moment. After we have some conversions in mind. For example, addition, it's exactly the same as we have it in the algebra notation, so there's nothing new here. Minus sign is a minus sign here. This is a typo, sorry. Multiplication, it is this little nice star. We use it in C++ to denote multiplication, as in math we either just write them next to each other. If bm means b times m, so sometimes we write them like this, bm, or b times m, as we've seen just now here. So b is multiplied by this bracket here, so we don't have a dot here, so sometimes we write them and sometimes it is not written, so it depends on what textbook you're referring to. Anyway, so let's go back here. Yes, division is this forward slash. Oh, it's again here, forward slash. So forward slash in math expressions are denoted for division, and we write them in math classes either like this, or a horizontal bar, or this little sample. None of these this one or that one is available in C++, but these are replaced by this one. And there's a new notation here for modulus, which is this percentage. This denotes R mod S, which means modulus. باقي القسمة, modulus. So modulus 5, if we have, for example, 5 modulus 2, it's nothing but the remainder of whatever number remains after dividing 5 by 2. So if we divide 5 by 2, we have only 2 and the remainder is 1. So 5 mod 2 is 1. And the integer division, 5 divided by 2 is 2. Let me write it down here so it's clear. Now if I have 5 divided by 2, if this is real integers, then it's 2.5. But if the division is an integer, integers mean عادات صحيحة, integers, so it's 2. 5 divided by 2, we have only 2 2's inside 5. We cannot have 3 2's. There are only 2 of them. 2 of the number 2. Now, what remains and what remains is equals to 1. Now this is the integer division and this is the remainder. Now 5 mod 2, this comes to this 5 mod 2 means modulus is equals to 1. This is not a division. This means modulus. Modulus is the remainder of an integer division. So modulus is nothing but the remainder of an integer division. Saying that, now I can write this down in C++ notation. So this is nothing but x equals, this shouldn't be capital X, yeah, x equals, then I have minus, then b, then multiply, because I have this little nice star to represent multiply, then I open this brackets, then a minus b, then I just close this bracket, then I have this to the power of 3. Then I have to do this 3 times. I know it looks silly, but this is what we have here in the meantime being, because we did not take any function notation. There are power functions that will save my time, but this will be in chapter 3. But for now, so I have minus b times a minus b 3 times to make the power of 3. Then I divide this by, okay, let me write an error. If I do 2 times a, then this is wrong, because the denominator is all this thing here, because they're all attached with a multiplication, and the denominator is only 2. So if I would like to attach and combine 2 times a as a denominator, so I have to embrace them into 2 brackets. So now this thing here is the denominator, which represent this one, and the numerator is all this one here at the beginning. It's an optional to have them in 2 brackets, but this is an optional. If you think it will be clear for your eyes to see them, then you are free to put 2 brackets, but it's not necessary. Now, fine. This takes us to a second question. What will be evaluated first? Now, everybody knows that the first thing to be evaluated is whatever have brackets, and then the weaker um, let me see here where we have it. 1 second. Yeah, so a different mathematic operator. Now, let's see other math operators as we have here. What second? This here, no, this one here. Now, these are the operators. Now, the operators at the top are evaluated first, and we go all the way to the bottom. Now, parentheses evaluate first. Next, we have this group here, multiplication, division, and modulus. They all have the same strength, so they are the second group to be evaluated. The third group is the addition and subtraction. So we have three groups. Going back to our example here. Now, if we have values for A and B, let's give them a value. Say, for example, if A is equal, this is a capital small letter, yeah. If A is equals to 4 and B is equals to 2, now we evaluate this thing here first. This is 4 minus 2 is nothing but 2, and this becomes 2, and this becomes 2. Now I take all the brackets or parentheses out here. Now I have 1 here. Now 2 times 2 is 4. Sorry, A is 4, so this is 8. So this is step 1. Now, since I eliminated all the parentheses, next step I go to the second strongest operator. Now let me go back here to remind you. The second one is the second group here, so it's multiplication, division, and the modulus. Yeah, so we go back here. Now there are for this minus here, this is a unary operator. So there are two schools of thoughts. If you consider it as a unary operator, it should be the first one in the pyramid, so this should be evaluated even before parentheses, but the book did not even mention it, so I am expecting as if it's a binary operator and there's a 0 before it, so it will be evaluated at the end. Actually, it won't make any difference in this scenario. So to go now forward, we evaluate if this is a unary operator, so this should be evaluated first. So this is minus, it should be minus 2. So this is minus 2. Now, since all these are of the same group, so we go from left to right. Now we multiply these together and we get minus 4. Now we multiply these together and we get minus 8, and we multiply these together, we get minus 16. Finally, we divide these and we get the number 2, and this is the resulting x that we have from having a to be assigned to 4 and b to be assigned to the number 2. X will be assigned to the number -2 at the end. Let's try and have you evaluate this on a sheet of paper, and please write down what will this end to. So for example, if x equals all this thing here, please write down what x is equal to in terms of C++ as we've seen before. So stop the video now and give yourself 5 minutes to write it down and type it in the appropriate place. Fine. So you're back here. I hope you got this exercise done right. So let us all solve it together. Now this is nothing but a, and then I multiply by 2 times c. Now this thing here is divided by 5 times b times, then I have 7 divided by, then I have 2 times, then I have a parenthesis a minus c times c times c. These are to the power of 3. Then I have to close this one, and then I have to close this one again for this one here, and I'm done. So I hope you got the same answer. Actually, I can reduce some of the parentheses here. For example, I don't need to have these together because it will be if all these are the denominator, it's fine. But if I'm gonna stick with the same notation, then I have to have this parentheses. But mathematical wise, it's the same value. The same can be said here. 5 multiplied by b. These are the two guys here. Then I have multiply. Then I have this whole fraction. If I'm gonna have it all together combined with a parentheses, then you have the option to either put all this into a parenthesis or just keep it as is in this notation. So since the question did not ask for the minimal number of parentheses, you will be free to have more than one answer to this question. So this is one solution to the question. I hope these two examples will give us the feel of how to translate any mathematical notation into a C++ notation. Now, to continue, let's have some programs here to evaluate whatever we've just written down there, just to make sure that it is correctly encoded. So as we've seen, new file, new, then we have project, then console, application. I'll call it math. Okay. Just call it math again. Save changes. Now I have here, let me remind myself of the first. Now let me copy this one here. I'll have this copied, and I just let me take it back I'll just have this back here. Yes. Now I'll just paste this back here again, and we have here b equals 2. So let me copy this thing here. I'll go to the compiler and cout then I just type it in. Now we have it like this. Now we compile and run. So this is what we have as an input. Then we will say cout assume a equals 2 and b equals no, sorry, a equals 4 and b equals 2. Okay, now cout again, then x is equal to x. Now this little fellow here is undefined. I'm gonna show you how it's gonna complain about it. See, it's undefined. It's undefined, undeclared. See, we have it undeclared. So because it have never been declared, so I'm gonna int x and give it a value as we have it before. So this is a value of x, but we have many problems here. B is undefined, a is undefined. Let me show you here. If I just compile, it will complain that, see, b is undefined, undeclared, and a is undeclared. So I just add them, a and b. We have here is x is equals to minus b times all the way the equation that we wrote here. Now if you notice that even if we put the equation, now the difference is this will be evaluated. This will be evaluated, but this will be printed on the screen. This will be printed on the screen, and x will not be evaluated at this stage here, but it will be evaluated here. But a problem is b is undefined. So b will have a random number, who knows, maybe minus 8,000 or something. So we must initialize a and b. We need not to initialize x. Who knows why? Why we need not initialize x? A simple answer is because x is never used before it is assigned a value. So the problem is, if you use a variable before assigning an initial value for it, you'll run into problems. This will hold for a and b. See, we never initialize them, and we're using their value to calculate some mathematical expression. To fix this thing here, I just assigned a equals 4 semicolon and b equals 2 semicolon. Now by doing this, you are assigning the value 4 for the variable a and assigning the value 2 to the variable b. Now you are assigning the value of whatever mathematical expression here evaluates to the value of the variable x. Now you should initialize x to some initial value if x is somewhere here. For example, if I put x here, so x will be undefined here because it's gonna be evaluated. But since we're never gonna use it before we assign a value to it, so there is no problem to initialize it. Usually every variable in C++ we should have the habit of initializing it. Initializing means putting an initial value, means a starting value. Most of our variables are initialized by 0, but this is not a rule of thumb. Now, one problem is sometimes student will put these two here. This will create a problem because even though it's initialized, but we use them here and the computer has no idea what B is here before it goes to this line. So it shouldn't see this line before A and B are initialized. So the correct way to do it is always initialize them before using them. Now, having said that, let me put and L here to have it looks nice, and we have 1 here at the end, so I don't have this press any key to continue exactly coming after the value of X. Then if I compile, whoops, I think I messed something here. Assume A equals 4 and B equals 2, then end L. What's it's complaining about here? It's end. Oh, so this is I said end L, but I missed the L here. Fine. Again, I mistyped it here. Now let's execute and see how it goes. So we have X equals this equation, and then assuming A equals 4 and B equals 2. Wow, so X equals -2, exactly as we calculated previously. So it's correctly transformed from the math notation to this C++ notation. So I will leave it as an exercise for you to make it to calculate this thing here, having A, B, and C entered by the user and not fixed as we have it here. So for example, here I fixed A and B to these values. I would like the user to have the opportunity to assign these values to whatever numbers dynamically at runtime. So you will ask the user, please enter A, please enter B, after you show the user that this is the equation that I'm gonna calculate accordingly. So once you print this one, just ask the user, instead of this assume thing here, just ask him to enter A and B. Finally, you will produce the X that results from the math equation. I hope this is clear, and you can always refer to the book page 33 to see the precedence of arithmetic operators, which is exactly what we've been explaining here. So this is page 33 from the book. It's 1.24, the arithmetic, and then this is a sample algebraic and C++ expressions we have here. The numbering here just shows us the order that these things are evaluated. So number 1, since this is multiplication, and we have multiplication, modulus, and division. All these are from the same group. So I go from left to right at the same group. So this is 1, and then I evaluate this one second, then this will be third, then there is no group 2 left in this expression. Now I go to group 3. Group 3, I have only this plus sign here, the addition, and the minus sign subtraction. So this will be evaluated first, since it is coming from left to right. It shows up before. So this is number 4 in the evaluation precedence. Then this is number 5, and finally I get the whole value of this mathematical expression. Number 6 is the assignment, where we assign the value to the variable here, as we've seen in our program a few seconds ago. And so this will give us a detailed example of the process that we've seen before in an example. So this will conclude our math operation. Now to go to the next topic of today's lecture, we must understand the logic operations. So algebraic equation, or the relation operators that has truth values. For example, less than, greater than. These are inequalities. In mathematics, we sometimes refer to, let me see here. Yeah, in math, if I'm gonna insert an equation, then in math we have things like this. But in the keyboard I can't find this notation, so instead we write it in C++ as so: less than or equal. And on the other hand, if I'm gonna have another notation which is greater than or equal, we don't have this in the keyboard, so we replace it with greater than or equal, exactly in the same order we say them. So this is less than or equal, this is greater than or equal. Now in math we have the notation that is not equal, this one. And in C++ we refer to it as not equal. I know it's kind of strange, but this is what we do in C++. Now you might think that in the math notation equal will remain equal, but no, you guessed it wrong if you just said yes, because this is an equal, a logical equal sign. And to make it different from the assignment, because you know that in assignments we evaluate whatever expression on the right hand side and put it in the left hand side, as we've seen a few moments ago here. So this is an assignment. This is not an equal sign. This is an assignment. Assignment means whatever value this expression will be evaluated to will be assigned to the variable that is on the left hand side. So equal will no longer sufficient for this purpose. This is why in C++, if we meant a logical equal, we should write it like this: double equal. So this is in C++. Double equals means equal. This is not equal, and this is greater than or equal, and this is less than or equal. So this will bring up all the logical operators that we have here in math. Sure, we have the normal less than is exactly as we have it in math, and the normal greater than the normal greater than is exactly as we have it. So there's no big changes in this one here. So these are the logical operators. Now, logic means true or false once they are evaluated. Now let's play with them in the compiler and see how we can have things done with logic. Now let me clean up everything here. We're back to this empty template. Back with this empty template. Now if I see out if I say 2 plus 3 and L, if I compile this one, I'll get a 5. Or should I get 2 plus 3 as is? Well, I got 2 plus 3. It was never added together because they are between these quotes. So if I would like to evaluate them, I should just write them 2 plus 3 here. So these will be evaluated now. They will be evaluated. If I'm gonna compile and run, now 2 plus 3 is 5. Now doing the same with logic, if I say 2 is less than 3 is, now I'm gonna say 2 less than 3. I'm just gonna execute this one. Yeah, I missed something. They should be in parentheses so that it is evaluated as an expression. Now, oh, it gave me 1. Now, what does it mean? 2 less than 3 is 1. What does 1 make any sense? Let me see. If I just change it and say 2 is greater than 3, let's see what will happen here. So 2 is greater than 3, and let's see what happens. It says 0. So any conclusions? Did you get anything out of it? Yes, as you all know that the age of computer is based on 0 and 1. So 0 means off or false, and 1 means on or true. Some devices still have this 0 and 1. Some computers have 0 and 1. Some switches have 0 and 1. So 0 means off or false, and 1 means true or on. Now, having that in mind, we know that, or we can conclude that 1 means yes, true. So when we evaluated this logical expression, 2 is less than 3, it was evaluated to 1, which is true. And when you evaluated 2 is greater than 3, it was evaluated to false, that is 0. Now we can have more evaluations, such as if, say, int x equals 5 and y equals 10. Notice instead of having x and y in 2 separate lines as before, I can have them in 1 line. I could do it like this, int y equals 10, but it will save me time and space if I just put this thing here next to this one and put a comma. So this is another way to do it that saves time. And you notice that I did 2 things here. I declared x and at the same time I initialize it. Remember what initialization mean? I've just said it this lecture. Initialization means giving it an initial value. Without this one it will work, but I need to have it say x equals 5 somewhere before I use it. So you should initialize any variable before using it. This is a very essential thing. You should always keep aware and keep your eyes on variables that you declare. So I'm declaring here two variables, one is x and one is y. X is not initialized at this stage here, but y is initialized with the value 10. Then at the next line here we have an assignment. This is an assignment. This is not a logical comparison or whatever. Now I'm gonna make a comparison here. I'm gonna say x equals to y. So as if I'm asking, is x equals to y? Then I'm gonna say, for example, 5, or let's say x times 2 is equals to y. I have to write it down here. X times 2 equals means equals y. So I'm comparing them. This should give me a 0 because 5 is in no way equals to 10. But if I multiply 5 by 2, then I get 10, which should be equals to y. So I should get here a 1. Let me double check and see what happens. See, so I have here x equals to y, this is 0, and x after multiplying by 2 will be equals to 1. This is 1, yeah, which means true. 1 is true and 0 is false, as we said. If I say less than or equal, this should be also true because it is equal. If I say here less than or equal, this should also be true because 5 is less than or equal to 10. If I'm gonna compile it, so I'll get the last two statements will be 1. Oops. X is less than or equal to y. Why did I get a 0 here? Let me double check. Yeah. Although I've changed it here, but what is evaluated is something else. So the computer doesn't even look at whatever is in between the quotes, double quotes. But I should change it here to reflect the change. The same has to be done in this line here. So if I double check it to just make sure that I didn't have any typos. Yeah. So now we have 1, 1 that reflects it's less than or equal. Now, having this said, we conclude the logical operations and the comparisons. Now we are ready to have conditions. We would like to have the computer make a decision using an if statement. So conditions are based on logical comparisons. So if I just clean up everything here and have this x and y remains as is, now I'm gonna write this code here. If, then I should have a condition here. If this condition is satisfied, means is if whatever between these parentheses is true, means evaluates to 1, then I will execute this statement that I'm gonna write here. Otherwise, just skip it. So this is the if condition. So if condition, as we've seen from the beginning of the course till now, that the computer will evaluate and execute each line of the code one by one. So it will execute this first, then it will execute this second, and it will execute this third, and this fourth, and this fifth, till it reach the end of the curly brackets, and that's it. It's done. So it never skips. So for example, it's not gonna run this one and skip this one and then run this one here. It never does it. So if statement will give us this power to skip some of the statements. Skipping a statement based on a condition is nothing but having the computer to decide whether to run it or just skip it. This decision is an intelligent behavior that we can give to our computer to either do a behavior or just do another behavior instead. This is when we get to the next chapter of having if else, but for now we'll have only either do it or leave it, means skip it. Now if I'm gonna say here x, okay, is less than y, this is my condition, x less than y, then I'll see out here, I'll type that y is greater than x. Now let me execute and see what happens. Y is greater than x. Now if I just put this one as 4, then if I execute, there's nothing. Means it skipped this C out, and I didn't have any other statements here, so it did not print anything. Now this short program doesn't make any sense, but if I have, for example, temp as a temperature, then I ask the user to give me, like, for example, cout, please enter the temp of today, something like this. Then cn temp, then I just give some smart responses. If temp is greater than, say, 49, I should say here, wow, it's boiling out there. You should be at home. We live in Kuwait. It's sometimes get really above 50. It's a desert. If temp is less than 0, cout I see. I like to have and L just for this new line not to bother me anymore. So I'll have and L here. Now, if temp is, now I would like to have a range. For example, if temp is greater, it is greater than 25, and so this is a new operator we're gonna see now. And is double and percent. And this is the logical and. If temp is greater than 25 and temp is less than 30, then cout go to a picnic, or go to the desert, or to the sea. Go to sea. Nice weather. Okay, I'm lazy to write and L. Fine. So let's execute this and see what happens. Now, please enter the temp of today. Now, if today is like 55, wow, it's boiling out there. Now let's execute again. If it's -5, I see. If it's, let's say, 23, oops, I have no response for 23 because I'm checking this range. It's greater than 25 and less than 50, and 23 doesn't fall into this range. So I have to put some default value here. So anything I print here, normal weather, this will catch any temperature, but it will also mislead. There's a fallacy there. I'll show you where. 23 normal weather, but if I say 50, it's wow, boiling, and then normal weather. So this shouldn't be a good solution. So I should have restrain it. So if temp, okay, now the range that is not covered, I'm gonna cover it now. We'll see how to do it. I should have some or here, or an and. So temp, I'm gonna cover it now. It is greater than 0 or equal, just because this doesn't cover the 0. So if it's greater than 0 or equal, greater than or equal to 0, and temp is less than or equal to 25, or so temp, so I'm gonna cover their upper range. So this will cover the lower range between 0 and 25, and I would like to cover the upper range. So these together are bind with and, because they should come together. Temp is greater than or equal to 0, and temp is less than 25. And we have that or. Then I have this upper range. Upper range means what is remaining. Temp is greater than or equals to 30, and temp is less than or equals to 45, because temp is 50 and above, it is covered. Now doing so, I'm covering all the numbers now. Everything is covered. Let me execute this one here and see what I have. Now if I say 5, normal. If I say 45, it's normal. it's covered. This is the upper range. If I say 25, go to the beach. 25, yeah, 25 actually I included with this normal because it will start from 26. Let's say 27, yeah, go to the sea. Minus 10, I see. And 65, wow. So all numbers are covered. So using this if statement, I could have the program to act differently based on the behavior, based on the numbers. So it has different behavior every time. It can make my program smarter by having more if statement with more complicated condition as we have here to cover things that are not covered. So this will conclude chapter 1. Everything here have been discussed all the way up to let's see, section 1.25 decision making. We've done with this with an example, and then there's an optional section 1.27. This is skipped. 27 is skipped, and you are ready now to solve the self review exercise. Please solve them all. Go through them one by one. All the answers are written at the following these exercises, so do them all, and then solve as many as the exercises as you can do at the end of this chapter, and you'll be ready for the next chapter in the next video. Next chapter we will explain control structure and go into more details and more complicated if statement. We have this if, else, and switch, while, do while, for, break, continue. All these are control structure that will give us more control to have smarter programs and doing more advanced and interesting programs for us. So bear with us and see you in the next video.